Good morning, students. Today I am going to explain a topic from the wireless communication, and its topic is applications and requirement of wireless services. Basically, in a broad sense, we all know that wireless communication is such type of a system in which wire is absent, or I can say wireless communication can be thought of to be a transmission of information between two or more inputs which are not connected through any wire media. And the idea of the wireless communication in very first time is basically launched by the G. Marconi, or I can say it is the idea of the G. Marconi, uh, who conclude that in the year 1897 in the English Channel that radio ability to provide continuous contact with ships sailing. So that was in 1897, and since then new wireless communication methods and services have been enthusiastically adopted by people throughout the world. The common communicating method includes all radio waves and infrared waves, visible lights, ultrasonic waves, and any such type of the waves in which we are not using any wire for communication or for transferring information from one place to another. Common application includes radio signals, mobile networks. In mobile networks, we are using Bluetooth, WiMAX, Wi-Fi, and even deep space radio communication mediums. Such alternative examples of the wireless applications of wireless technology includes GPS unit like wireless computer mouse, keyboards, and handsets. Also, we have seen garage door openers and headphones like radio receivers, broadcast televisions, satellite televisions, and cordless phones. All, if we see all these examples, we can see that one thing is common in all these, that they are not using wire for communication from one point to the another points. So anything which we see around us, or any technology which we see around us who are not using wire, they all are the example of the wireless communication. Although mobile which we are using is one of the common example of the wireless communication, and we are using mobile for various application, not only to communicate with the others but many more. So I think students, you will getting idea that what is really mean by the wireless communication. So if I want to set up some wireless communication, then what should be the basic requirement of the wireless setup? So being as the student of the electronics or of the students of the engineering, we know that if I want to transmit or receive information, there must be a transmitter, receiver, a source from which we get the information to transmit, and channel. Channel is what? Is the medium. Is the medium by which I can transmit information from a transmit to receiver. So the basic requirements is the source, and we all know that source is a device which generates signals for transmissions, which can be itself a source or a transducer. or a transducer which converts physical phenomena like temperature, pressure to electrical or optical signals during communication. There must be a transmitter and a modulator. We all know that what is modulation. And in the transmitter, we can write that transmitter is a device which modulates the source signal onto an energetic carrier wave for transmission purpose. During transmission, channel is transmission media which carries the modulated wave during transmission. And if we are using wireless communication, that means channel should be air. There won't be any physical transmitting media. If we are using wireless communication, that means channel should be the wireless. And the last requirement is the receiver and the demodulator. These are the counterpart of the transmitter that separates message signals from the received signals, from the received ones. So now we understand what is the wireless communication, what are the requirements to set up for the wireless communication. But while setting up any wireless communication, we have to face certain social and economic impacts. Or I can say that if I want to set up, if I want to design new setups, that means I have to face some social impacts as well as the economic impacts, because what type of the idea I have inside me, it doesn't be flexible for everyone. So from the point of view of the wireless communication, the social impacts are the wireless medium or the system which I want to design should be developed in social links. So should develop social links or should improve in social links. The creation of social capital or social empowerment, using of mobile phones during emergencies, the reduced need to travel. These should be the social impacts. Now, and many more are possible, but these are the general social impacts. And if I want to explain some economic impacts, then I must include that improvement in the market information flows, the reduction in price discrepancies, less spoilage of the resources, the increased business opportunities, the improving productivity, the better employment opportunity, the increase in GDP and foreign direct investment. These are the some economic impacts, or I can say what type of the medium or what type of the wireless communication which I want to design, and it should be economic so that general people can easily afford, normal people can easily afford it. Now, if next slide is what? Now, what should be the advantage of the wireless communications? Then I must say that there are number of advantages of the wireless communication technology. And apart from that, what type of the wireless communication we have? It should have wireless networking and wireless system over wired communication, like cost, mobility, ease of installation, and reliability. So the very first advantage which I want to cover is the cost. The cost of installing wires, cables, and other infrastructure is is eliminated in wireless communication, and hence lowering the overall cost of the system compared to wired communication system. Also installing wired network in buildings, digging up the earth to lay the cables and running those wire across the street is extremely difficult, costly and time consuming job. And if we see some examples, also we see in the historical buildings that drilling holes for cable is not a best idea, as it is destroys the integrity and importance of the building. Also in older buildings with new dedicated lines for communication, wireless communication like Wi-Fi or wireless LAN is the only option. So this is one of the most important part of the wireless communication, or we can say most advantageous part of this communication, that without destroying our old historical buildings, we can implement a new mean of communication. Also, mobility is the main advantage of the wireless communication system. It offers the freedom to move to move Mobility is the main advantage of the wireless communication system. It offers the freedom to move around while still connected to network. This is the reason why we want to have a wireless communication. We are mobile. We can move anywhere without disturbing our communication networks. Also, ease of installation is also one of the most important advantage. The setup and installation of wireless communication networks equipment and infrastructure is very easy, as we need not worry about the hassle of cables. Also, the time required to set up a wireless system like a Wi-Fi network is very less when compared to setting up a full cabled network. Also, this is easy to find, uh, any problem if created during the wireless communication setup of channel or network. Next is what reliability. Since there are no cables and wires involved in the wireless communication, there is no chance of communication failure due to damage of these cables, which may be caused by environmental conditions, cable splice, and natural diminution of metallic conductors. And the next advantage is disaster recovery. In case of accidents due to fire, floods, or other disaster, the loss of communication structure in wireless communication systems can be minimal. Apart from various advantage of the wireless communication, we also have some disadvantage. As we know, every system has two parts, and if the system is have some advantages, also the same system have some disadvantages, although the advantages are more as compared to the disadvantage. That's why we prefer the modern systems. So in the very first disadvantage of the wireless communication is that even though wireless communication has number of advantages over wired communication, there are few disadvantages as well. The most concerning disadvantages are interference, security, and health. And obviously the health is on the top. Basically, with the wireless communication, we are using all the radio waves. So maybe some people have disadvantages of this. Interference. The next disadvantage is interference. Wireless communication system use open space as the medium for transmitting signals. As a result, there is a huge chance that radio signals from one wireless communication system or network might interfere with other signals. The best example is Bluetooth and Wi-Fi, that is wireless LAN. Both these technologies use the 2.4 gigahertz frequency for communication, and when both of these devices are active at the same time, there is a chance of interference. Okay, so students, these are the disadvantage of the wireless communication. Next, we have many more. One is the security. One of the main concern of the wireless communication is the security of the data. Since the signals are transmitted in open space, it is possible that an intruder can intercept the signals and copy sensitive information. Also, we have health concerns. Continuous exposure to any type of the radiations can be hazardous, even though the level of RF energy that can cause the damage are not accurately established. It is advised to avoid RF radiation to the maximum. So instead of using mobile direct contacts, you may be, if possible, then use headphones. Now, this is the block diagram of the wireless communication. Also, it is explaining the basic elements of the wireless communications. In the typical diagram of the wireless communication system, we are able to see two paths. One is the transmission path, the other is the reception path. The transmission path is concerned with the transmission of the signal, and the reception path is concerned with the reception of the signal. So the very first block of the transmission part is the source coding, and a source coding will receive the signal or the data or the information as the input. Then the after source coding, I have encryption block. I have encryption block where I can encrypt my data with the technologies. And the output of the encryption block is connected with the input of the channel encoding, in which where I can encode the encrypted data. Then I need to modulate this coded signal, and this signal, after modulation and multiplexing with the antenna, it can be transmitted through the channel, wireless channel, or air can be used as the wireless channel. Then somewhere at the location, I have my reception antenna where this signal is received by the reception antenna. Then again, I have to reverse process what I have did in the transmission path. I have to just reverse all my process in the transmission path. So after multiplexing, what I have to do, I have to demultiplex the signal. Then the output of the demultiplex signal is demodulated. The demodulated signal is received by the channel decoding methods, where I can decode my information. After decoding, I have to decrypt my data, and after decryption of the data, I can receive the information which I have really sent it to the transmission, sent it to the by the transmission path. and here I have received estimated information. Although there might be possibility of some sort of degradation of the signals, interference, but they can be, but we can easily obtain our the original data. And this is all about the basic elements of the wireless communication. Then what comes next? Now there are the various type of the wireless communication systems are available. Today people need mobile phones for many things like talking, internet, multimedia, etc. All these services must be made available to the users on the go. That is, while the user is mobile. With the help of these wireless communication services, we can transfer voice, data, video, images, etc. Wireless communication system also provide different services like video conferencing, cellular telephones, paging, TV radios, etc. Due to the need for variety of the communication services, different types of wireless communication systems are developed. Some of the important wireless communication systems available today are, which we can easily find around us, are the television and the radio broadcasting, satellite communication, radar, mobile telephone system, global positioning system, infrared communication, wireless LAN, Bluetooth, paging, cordless phones, radio frequency identification, that is RFID, and many more things. So when a signal travel from from transmission antenna to the receiving antenna, the signal is interfered by many paths, and that is called the multipath. So in one sentence, if I explain this, I can say, while doing wireless communication, interference caused by multi-path propagation. What actually mean by the multi-path propagation? If I send any signal, it can be reflected by a door, by wall, by window, by vehicles, by any tower or any such signal. So a signal from transmitter to receiver, it's hardly possible to go by line of sight, but it can propagate by multipath. So multipath propagation can give rise to interference that can reduce the signal to noise ratio and reduce bit error rates for digital signals. One cause of a degradation of the signal quality is the multipath padding. So, however, there are other ways in which multipath propagation can degrade the signal and affect its integrity. Basically, multipath padding is introduced when our signal is propagated with the different uh, materials when it travels from a wall to tower, then from by any trees. Every time when it interfere with any such type of the things, our signal quality is degraded, and that will give rise to multipath padding. One of the ways which is particular obvious when driving in a car and listening to an FM radio, at certain points the signal will become distorted and appears to break up. This arises from the fact that the signal frequency modulated, and at any given time the frequency of the received signal provides the instantaneous voltage for the audio output. If multipath propagation occurs, then two or more signal will appear at the receiver. One is the direct or line of sight signal and the another is a reflected signal. As these will arrive at different times because of the different path lengths, they will have different frequencies caused by the fact that two signals have been transmitted by the transmitter at slightly different times. Accordingly, when the two signals are received together, distortion can arise if they have similar signal strength. This is the reason why multi-path fading occurs. Also, signals are received in a terrestrial environment, that is where reflections are present, and signals arrive at the receiver from the transmitter by a variety of paths. The overall signal received is the sum of all the signals appearing at the antenna. Sometimes these will be in phase with the main signals and will add to it, increasing its strength. At other times, they will interfere with each other. This will result in the overall signal strength being reduced. So multi-path fading can be detected on many signals across the frequency spectrum, from the HF band right up to the microwaves and beyond it. It can cause signal to rise and fall in strength. Also, apart from the multi-path fading, we also have release fading. Release fading is the name given to the form of fading that is often experienced in an environment where there is a large number of reflection present. And the best example of the release fading we can see in a forest of the dense trees, where our signals cannot be received properly due to the thickness of the tree leaves. Okay. Now next is what? We have some more form of the multipath propagation. So another form of the multipath propagation interference that arises when digital transmission are used is known as the intersymbol interference. This arises when the delay caused by the extended path length of the reflected signal. If the delay is significantly proportion of a symbol, then the receiver may receive the direct signal, which indicates one part of the symbol or one state, and another signal which is indicating another logical state. If this occurs, then the data can be corrupted. One way of overcoming this is to transmit the data at a rate. The signal is at a rate by which the signal is sampled only when all the reflections have arrived and data is stable. This naturally limits the rate at which the data can be transmitted, but ensures that data is not corrupted and the bit error rate is minimized. To calculate this, the delay time needs to be calculated using estimates of the maximum delays that are likely to be encountered from the reflections. Also, using the latest signal processing techniques, a variety of methods can be used to overcome the problems with multipath propagation and the possibilities of the interference. Now, apart from all these fading and interference, we have some more technical challenges. We have to face some more technical challenges in the field of the network, that is multipath propagation, spectrum limitations, energy limitations, user mobility, noise limited system, interference limited systems. Now I can explain all this one by one. So what we can understand with the multipath propagation. For wireless communication, the transmission medium is the radio channel between the transmitter and the receiver, which I have explained. The signal can get from the transmitter to the receiver via number of different propagation paths. In some case, a line of sight connection might exist between the transmitter and the receiver, or the signals can get from the transmitter to the receiver by being reflected at or diffracted by different interacting objects in the environment. What are they available? The number of these possible propagation path is very large. Each of the path has a distinct amplitude, delay, that is runtime of the signal, direction of the departure from the transmitter, and the direction of the arrival. Most importantly, the components have different phase shifts with respect to each other. So when our signal reflected from different types of the materials which are available at his location, this can be termed as the multipath propagation. Now, the next limitation is the spectrum limitation. As we know that India is our developing countries, and we have very limited source for the spectrum. The spectrum available for the wireless communication service is limited and regulated by the international agreements. For this reason, the spectrum has to be used in a highly efficient manner. Two approaches are used. We have regulated spectrum usage, where a single network operator has control over the usage of the spectrum, and unregulated spectrum, where each user can transmit without additional control as long as he complies with certain restriction on the emission power and bandwidth. Also, we have limited energy. So a truly wireless communication requires not only that the information is sent over the air, but also that the mobile station is powered by one-way or rechargeable batteries. Otherwise, MS mobile station could be tied to the wire of the power supply. Batteries in turn impose restriction on the power. Also, the power consumption of the devices. The requirement from small energy consumption results in several technical imperatives. The power amplifiers in the transmitter have high efficiency. Signal processing must be done in an energy saving manner. Maximum transmission power should be used only when required. For cellular phones and even more so for sensor networks, an energy efficient standby or sleep mode has to be defined, so we can easily use our energy in the efficient way. And the next technical challenge is the user mobility. Mobility is an inherent feature of most wireless system and has its own importance. Padding has already been discussed above. A second important effect is particular to mobile user is cellular system, and the system has to know at any time which cell a user is in. If there is an incoming call for a certain user, the network has to know in which cell the user is located. If an MS mobile station moves across a cell boundary, a different base station becomes the serving base station. In other words, the mobile station is handed over from one base station to another. Such a handover has to be performed without interrupting the call. As a matter of fact, it should not be noticeable at all to the user. That's why we never feel when we move from one part of our state to the other state, है ना? If our call never dropped when we move from one cell to other cell, है ना? This is the reason we have why it happened, because we have a handover. We have handover techniques, and this is the main technical challenges which we have to take. Also, the noise limited system. Wireless systems are required to provide a certain minimum transmission quality. This transmission quality in turns require minimum signal to noise ratio at the receiver. Now, if consider a situation where only a single base station transmitter and a mobile station receives, thus the performance of the system is determined only by the strength of the signals and the noise. As the mobile station moves further away from the base station, the received signal power decreases, and at a certain distance, the signal to noise ratio does not achieve the required threshold for reliable communication. Therefore, the range of the system is noise limited. Equivalently, we can call it signal power limited. Depending on the interpretation, it is too much noise or too little signal power that leads to bad link quality. And next is what I have, interference limited system. So as to understand the interference limited system, consider the case that the interference is so strong that it completely dominates the performance, so that the noise can be neglected. Let a base station cover an area that is approximately described by a circle with radius r, and at the certain location of the base station. Furthermore, there is an interfering transmitter at a distance capital D from the desired base station, which operates at the same frequency and with the same transmit power. How large does D have to be in order to guarantee satisfactory transmission quality? 90% of the time, assuming that the mobile station is at the cell boundary. Now, this is the worst case which we can consider. The computations follow the link budget computation of the previous section. As a first approximation, we treat the interference as Gaussian. This allows us to treat the interference as equivalent noise, and the minimum SIR and the minimum SIR takes on the same value as SNR minimum in the noise limited case. So with these technical challenges, with all these above six technical challenges, and we have many more, but these are the some on the top list. Now, I think from all these discussion, just I want to explain you these two questions. Mention two different effects of the multipath propagation. If I would say, students, mention two different effects of the multipath propagation. So what comes under this multipath propagation? That means every path or number of paths from which our signal travel can be considered as the multipath propagation. So what should be the answer? Multipath propagation leads to fading and intersymbol interference. These are the two effects generated with the multipath propagation: fading and the intersymbol interference, or I can say ISI. What fading says? Fading means a simple receiver cannot distinguish between the different multipath components. It just adds them up so that they interfere with each other. Interference between them can be constructive or destructive depending on the phases of the multipath components. The phases in turn depends mostly on the run length of the multipath components, and thus on the position of the mobile station and the interacting objects. For this reason, the interference and the amplitude of the total signal changes with time if either transmitter, receiver, or interacting object is moving. This affect, namely the changing of the total signal amplitude due to the interference of the different multi-path component, which is actually called as the fading. Also, ISI say intersymbol interference in a system with large bandwidth and thus good resolution in the time domain. The major consequence is signal dispersion. In other words, I can say the impulse response of the channel is not a single delta pulse, but rather a sequence of pulse corresponding to the different multipath components, each of which has a distinct arrival time. In addition to having a different amplitude and phase, this signal dispersion leads to intersymbol interference at the receiver. So students, I think you will know the two reasons for the multipath propagation. One is the fading and the other is the intersymbol interference. So this is all about for the today's lecture, and I think one portion is remaining, है ना? Then the second portion which I have to explain or to discuss with you is how to overcome spectrum limitation in a spectrally limited region. So if I answer in one line, then I must say that proper frequency splitting and reuse can increase the reusability of frequency spectrum. So this all we have to emphasis on these the factors that how to overcome the spectrum limitation. So students, this is all about for the today's session. Thank you, students.